Hi everyone. I just want to start off today's video by saying please don't forget to complete the attendance form. Alright. I also want to mention that everything covered in today's lesson will be considered extra credit. So if, because it's a lot of math. I'm going to go right into it. We're going to be doing a lot of math here. If that's not something that you really want to invest in, no worries. Just make sure you do the attendance form, go on with your day, and I hope the rest of your education journey today is, fulfilled through your other classes. But, if you really are interested, I'm going to show you guys how to draw an equilateral triangle in Canvas, and you can actually apply these to your mini projects, which I'll give you guys another couple days to work on, because I know I underestimated the difficulty of the project for a lot of you. All right. So now that the people who are still here are the ones that want to actually do this extra credit bit, let's get started. All right. So what we wanted to do, or what I put in for the mini project, was an equilateral triangle that would rotate and scale in the center of our canvas. And a lot of you attempted to do that and found it a little tough to do. All right. And that's because it's really hard to get the exact measurements the exact positions of the vertices of an equilateral triangle centered on our canvas, because, well, it doesn't really, you can't just put solid numbers in like 20, 15, whole numbers, integer numbers that will give you an accurate equilateral triangle. That won't end up working out for you. All right. So what I'm going to show you now is how to actually find the values and put them in yourself. All right. Now, what we wanted to do is have this equilateral triangle centered on our canvas. Now, we're going to translate our canvas to 100, 100, or you can translate it to C1 dot width divided by 2, C1 dot height divided by 2. Both of those will bring you to the center of your canvas. All right? And that is going to be our reference point, 0, 0. And what we want to do is we want to draw these three vertices. We'll just say vertice 1, 2, and 3. From that center, in relation to that center. And in order to do that, we need to find the x and y distance, or like how much you have to travel in the x and in the y from this center to these vertices. All right. And to do that, we need to know the length of this line segment right here, the length of these two line segments, and that's it. Because obviously, if you know the length of these two line segments, you're going to end up knowing the length of this line segment as well. And the reason being is because the center of an equilateral triangle is always where the perpendicular bisectors of each angle in that triangle meet. So we have this perpendicular bisector, which will also perfectly split this side in two, this perpendicular bisector that perfectly splits this side in two, and this perpendicular bisector that perfectly splits this side in two. And since it splits this side in two, if we know the length of this line segment right over here, we know the length of that line segment because they are the same. Okay. Another little bit of information we know, since an equilateral triangle is 60 degrees in each angle, we know that if we want to take out this little orange triangle that I highlighted for you, and I made much larger over here, that this is a 30-60 triangle, special triangle, which you should know the relationships to. I put the relationships on the side lengths for you already, but you should know this. All right, this is something that they, one of the two special triangles that they teach in your geometry class. You have the 30-60-90 and then the 45-45-90, I believe, are the two that they teach. All right. And so we can take this out, and we actually, if we wanted to know the value of this segment here, it's useful to take out this purple triangle, which again is a 30-60-90, and I put here. And again, the reason we know this, well, if this is a perpendicular bisector of this angle right here, and every angle is 60 degrees, this must be 30 degrees. We know that this is 90 degrees because we have this perpendicular bisector here, splitting this perfectly in two. And so, if you subtract 30 and 90 from 180, you have a remaining 60 degrees. Similarly, we have this triangle. Okay, now that I've talked your ear off, let's actually go into finding out what these values are. Now, remember, we want to know what, here, let me just do it in red. We want to know the value of this one, this side, this side, and we want to know this right here in our triangle, and the way we're going to find that out is by getting the value of this entire bit right here, and then subtracting whatever we get down here, right? Because this whole thing right here is this whole thing right here, and this right here, I'll do it in another color, is this little segment, right? And if we subtract this segment from the whole segment, we just get what's left over here. All right, let's do some math. I'll get rid of that ugliness. Let's do this tiny triangle first right here. Now, let's say we have to know what we want the total side length of our equilateral triangle to be for this to work. So I'm going to say I want each side of this equilateral triangle, let's say I want it to be 40, right? So 40 is the side length, right? Let's just establish that right now. I misspelled length. Mr. Sands teaches computer science and math. Don't expect him to know English too well. All right, you know what? Let's do the purple triangle first because we have this side length of 40. All right, if we know this side length is 40, we already know the value of 2x here, right? 2x has to be equal to 40. That's the length of this side right here. All right, if we know the value of 2x, we should also know the value of x right here, right? If 2x is 40, to get x, just divide both sides over here by 2. You know, I'll do it just for the sake of the fact that we have the ability to display it, though a lot of you can do this in your head and figure out that x is equal to 20, right? All right, so we know the value of x. Beautiful. And that actually checks off one thing that we needed to know. We know that this value is going to be 20 over here. X equals 20. All right. And now we need to know, well, what's x rad 3? Super easy. We just stick a rad 3 on the end of x, which is 20. So we know that this is equal to 20. How can I draw this without running into it? What a champion. Oh, that's supposed to be a 3. I'm not a champion. I'm a loser. I'm okay, guys. Love yourselves. All right, so this is 20 rad 3. All right, or I tried my best to write that. Hopefully you understand. This is 20 times the square root of 3. Yeah? All right. So we already know this whole side length. We know what this last tiny bit over here is. Beautiful. Okay. Now let's get over to this triangle. Now, this triangle has similar labels, but we know that this bottom side right here is the same, is this side that we're looking at over here in our triangle. Now, we already said over here that that side is 20, right? So it's going to be the same over here. So this x rad 3 over here in this tinier triangle, that it looks the same because we just zoomed them out. This is going to be still equal to 20. So x rad 3 for this triangle is equal to 20. We don't even need to know what 2x is over here. We're not bothered by that. We don't have any issue in knowing what this side length is going to be. But we do want to know, what is this going to end up being? Well, we know x rad 3 is 20, yeah? So if we wanted to find x, all we have to do is divide out the square root of 3 from both sides over here. So I have x rad 3 equals 20. Divide out radical 3 from both sides. Boop. And we have over here now that this side length is equal to 20 divided by radical 3, or 20 over radical 3. So now we know not only that this is 20, we know that this right here is going to be 20 over radical 3. We know that this entire length is going to be 20 rad 3. How do we find this small segment? Well, again, we said we take the entire length, which was 20 times radical 3, and we subtract this small segment, which was 20 divided by radical 3. All right, so this value is the length of this segment right there. All right, a bunch of ugly numbers, but with this information, we can draw our equilateral triangle. All right, I'm gonna go into the project now. I've already put some stuff here for you. We're gonna put some more things in, but we have this begin path, a bunch of move tos, a close path, and then a fill. This is how we can draw our triangle. Now, before we actually go into putting in our things, make sure that for all of you, we did that translate that I mentioned, because we want to have all of our transformations happening in regards to the center of our canvas. And by default, they all happen in regards to 0, 0 up here. So I'm going to translate by 100, 100, which is the same as saying C1.width divided by 2, C1.height divided by 2. You know, if you're more comfortable, just put 100, 100 there. It's the same thing because the width is 200 units and the height is 200 units. All right, and then what I'm going to do, just when I'm done with this, I'm going to translate by the negative of those two values. Let me actually just put negative 1 times so that we don't actually just get an error for just throwing a negative out there for no reason. All right, so we want to just translate by the negative value of those width and heights divided by 2. All right, so we have move to, line to, line to. Now, what I want to do is I want to find each of those vertices. Now, let's see. Let's do this first one. This first vertice, or I think it would just, if we want to do is it vertex? Yeah, this first vertex, my mistake, proper language. This first vertex, where is it in relation to my center point? Well, you see, it looks like it's directly above it, which means that we have 0 change in the x coordinate. We don't need to touch that at all. And we go up by the length of this line segment, which we found to be 20 times the square root of 3 minus 20 divided by the square root of 3. All right, so let's go back into this. For this move to, we can say that the x that we move is 0 from that center of our canvas. And now we want to go up by 20 times the square root of 3 minus 20 divided by the square root of 3. Now, we need to know here that to go up in the y, you have to, go negative, right? Because in Canvas, as you increase your y, you go down. And as you decrease your y, you go up. So what I'm going to do here, if I go back to this, I just need to take this whole bit and make it negative by multiplying it by negative 1. Well, if I do that, this becomes negative 20 times the square root of 3 plus 20 divided by the square root of 3. Or I could just flip these around because of the commutative property of addition and make this 20 divided by the square root of 3 minus 20 times the square root of 3, which I think is what I'm going to do. Commutative property. Everyone loves it. All right, so I'm going to put this in. Now, to do that, I'm going to just put 20 times. Now, if you want to get the square root of something in JavaScript, we've already done math.py. A lot of these math terms that we need are going to be in that math object that we have there. So I'm going to just do math or math class, whatever you want to call it. Math.square root of 3. All right, and actually for this first case, I'm pretty sure we're dividing it. So we'll say 20 divided by math.square root of 3 minus 20 times math.square root of 3. All right, that's our first point. Now we want to go to our next one, which is here. All right, now we need to know how much we're moving in the x, how much we're moving in the y. Now we know that the length of this this line segment here is 20 divided by the square root of 3. That's going to be our change in y. And we know that this right over here is just 20 because it's half of our side length. So that's going to be our change in the x. Let's put that in here. We can say the next vertex is at 20. That's our change in x. And 20 divided by math dot square root of 3. And you know what? This other vertex is just on the, a reflection of that because it goes down that perpendicular bisector. So all we got to do is change the x value to the negative of what it was. So that'll be negative 20, and then we go down 20 divided by math dot square root of 3. All right, hopefully Mr. Sands didn't make any mistakes, and when I run this, you're going to see a nice equilateral triangle in the center of my canvas. Beautiful. I love it. All right, so if you were following along, you can now use these as your coordinates for your triangle and adjust. And if you do, and you put this in your mini project as the final product that you submit, you'll get, let's say, 5 points extra credit. And if you really, if you really want to, this is not a hard thing to implement. But yeah, that's a fun bit of math there for you guys who are trying to get the equilateral triangle there. Once again, don't forget to do the attendance. Join the Discord if you haven't already. And I hope you guys are having, a good day today. I know it's been a tough few months, wow, for us, but we can pull through it. We're strong people, us New Yorkers. All right. That's all I got to say. Have a great day, everybody. Bye.